So very pleased to welcome two back-to-back keynotes. The first one, we're going to hear about an interdimensional mapping protocol to connect virtual worlds. And this paper is from Roderick, Dietz, and Nevelstein. So over to you guys.
So I guess we're back from the lunch. I'll give a bit of an introduction to this topic in a hands-on way, if you don't mind, because there's a kind of conceptual background of it that goes back to both of our background in physics, Roderick more than me, but a conceptual idea. And I don't know if anyone has ever tried to just imagine geometries, but if you take like a cube in your hands, it's maybe easier for those of you who've used Legos or anything else. I don't know if anyone can do it or imagine you have a kind of cube here, and then you stack cubes side by side or on top of each other. And pretty much one of the things you'll do if you do this as a mental exercise or you do it anywhere else, you find that everything that you see can basically be mapped through cubes. You can kind of create a cube that corresponds to every area of every space that you experience in your normal 3D reality. And another auxiliary benefit of this, if you're into mathematics or computer science, is that these cubes are perfectly composable. That means that for each cube, you can have another cube that is effectively outside of that cube and contains all the cubes that are inside of it. And what this allows is something that's very simple but also sort of profound, in the sense that I can then create a way of addressing to basically describe the location of any object anywhere in 3D space, our galaxy, Mars, this world, some alternative world, that's based on similar physics, that is effectively the address for that particular space by kind of what cube it is contained in, from the size of a planet all the way down to the size of your toenail or some bacteria that lives in your belly. So that is a kind of interesting concept. It relates to fractals, it relates to other things. But that led me to think, that as people were talking about the metaverse, as people were building more and more game worlds and virtual worlds, that there was an opportunity to create an addressing system that goes from any world to any other world. And for those of people who are familiar with the world of psychedelics or other types of things where people are in different kind of spaces that you can visualize, potentially it even bridges into other types of worlds that exist in your imagination or in virtual reality, and you have a concept and you say, well, where does this thing exist? Normally there's no particularly easy way of describing the where. It's just kind of a numinous experience, or you can get the philosophical version of it, the precise phenomenology, if you will. But the reality is that we kind of have this bridging gap from a kind of experience that is in my mind, that is in virtual reality, that then connects to some version of this physical reality, that then connects to some kind of game world physics engine. And so with this in mind, I became a founding member of this group called the Open Metaverse Alliance, which was dedicated to making protocols that were for various people making kind of virtual and game worlds. And then I became connected with Roderick, who has a background basically building physics engines from scratch and doing various things, and was already leaning into the specific idea of how do you connect these different worlds and kind of rendering engines together. And with that, Roderick, take it away.
Thanks, Joel. Okay, so bear in mind what Joel said about addressing and the idea of representing spaces, because we'll come back to that probably about midway through the talk. But first of all, we'll rewind a little bit to 1929. A lot of people credit Stanley G. Weinbaum's 1935 short story, Pygmalion Spectacles, as the first fictional virtual reality, but I like to look a little bit further back to 1929. Green, Payton, Wertenbaker wrote another short story called The Chamber of Life, where he laid out the principle of a virtual world. a machine that you can enter that provides an effective virtual experience that feels like life. Really interesting character. He joined NASA later in life and was quite instrumental in their communications department. So in 1938, however, the avant-garde theatrical practitioner, Antonin Artaud, I think I said that correctly, coined the phrase réalité virtuelle or virtual reality. He meant theatre, and he was talking about an immersive style of theatre, a style of theatre that created a sensory experience that addressed directly the subconscious of the audience and interacted directly with the audience. Now, moving on to 1984, William Gibson publishes Neuromancer. Now, Neuromancer coins the term the matrix, interestingly enough, and it's a little bit different from the sort of worlds we'll be discussing, because in Neuromancer, you're not actually dealing with a simulated world, but it's more of a fully immersive, sensory, direct experience of the network itself, which at that time was in its infancy, the internet. The web had not yet been created. And then in 1992, Neil Stephenson gives you the whole ball of wax. The metaverse, he coined the phrase, and this is a simulated virtual world that is part of a network that spans the globe, but provides simulated jobs, simulated socializing, a place where you can live and work, you can own property, you can do much of the stuff of daily life within his metaverse. Ernest Cline develops this idea in Ready Player One to be somewhere where people do spend a lot of their lives in these virtual worlds, particularly for things like education, for sports and so on. Now, rewinding a little bit, the actual technical development of these worlds was obviously came a little bit behind the imagination. In 1968, Ivan Sutherland, the great pioneer of simulation, created the first, essentially, VR headset, or actually it was augmented reality. And with what was called the Sword of Damocles, for obvious reasons, you could immersively view a floating cube in front of your eyes. That was pretty much all it did, but it was crucial to the development of what followed. Now in 1984, Jaron Lanier and VPL Research introduce the phrase virtual reality to wider consciousness. And they created headsets, they created haptic bodily interfaces, and they created 3D virtual worlds that could be networked and that people could join in with together to experience things as widely varied as military training or what it's like to have 8 legs and be an octopus. Which kind of looked like the future until in 1989, Tim Berners-Lee introduces the World Wide Web, which is a completely different kind of network. Non-temporal, non-spatial, a worldwide interconnected web of documents, which had such an impact on society and on the commercial world, on the world of imagination, that it was hard for people to, I guess, see past what its actual design was, which is non-spatial, non-temporal. So in 1994, VRML was proposed as a way of saying, well, surely the web can create a virtual, 3D virtual spatial internet. And it was proposed as a markup language, just as HTML is a markup language, which is it's an odd formulation because the web is fundamentally non-spatial. It's fundamentally non-temporal. It's about concrete items of data. There are spatial and temporal elements that we've all added to it over the years, especially with scripting, but at its core, the paradigm is not designed for that. Now, a group at the US Naval Postgraduate School in Annapolis saw some of the issues with this, and they proposed VRTP. And the idea with VR Transport Protocol was that we couldn't use HTTP for interlinked virtual worlds. It was the wrong technology. We needed something that was real-time, something that was low latency, unreliable. Now, VRTP didn't get very far. It was probably the wrong time for it because there wasn't a real headset market. Headsets cost tens of thousands of dollars if there were going to be any use. And there weren't a lot of virtual worlds outside of gaming. And in gaming, obviously, you had things like Doom, which pretty much bypassed the whole issue by using proprietary protocols. So what do we have today? Well, we don't have a spatial internet. We don't have a metaverse. We have an ecosystem of applications on laptops, on desktops, on phones. You launch an app, and you're in that app's walled garden, walled silo. You can't connect from Facebook Horizon to VR chat. You can't connect from Outspace to Rec Room. You can't use the Outspace, well, Outspace no longer exists sadly, but you can't use the VR chat client to connect to Rec Room. You have to close that down, go into the other client, launch it up, and you're in the new application. But that's not a spatial internet. So in my group, we propose Teleport, which is essentially fulfilling the role that VRTP was meant to fulfill. The idea that from any client that understands the protocol, you can connect to any server that understands the protocol. And that would give you the possibility of a navigable spatial internet. Web-like in its behavior of having the same client and the same protocol connecting to any server, and anyone, crucially, can build a server. And that's the ideal and possibly the future, but that's not where we are right now. Right now, we've got an ecosystem of different servers running different protocols. You have a proprietary client, say Facebook Horizon, using a proprietary protocol, a Horizon protocol, whatever that is, we don't know, to connect to Horizon's own servers. There are serverless systems. There are browser-based systems using, say, WebXR, even 2D systems. We don't have a navigable network. You can't get from one to the other easily, smoothly, seamlessly. So this is the challenge that we've addressed in this paper, which is what we call interdimensional mapping. If you have two clients, client A and client B, and you have a user who wants to move between them, how is that going to happen? How does that work to give us a navigable network where we can move from one to the other easily, seamlessly, to give us that property of the web, which is that it's something that you can just explore. This is what we designed. There are two phases essentially to the protocol. And this is an overarching protocol. It doesn't really care how each source, how each client talks to each service. What it cares about is the intermediary of how those services can join together. So at the start, you're connected by a source client to a source service. And the source service says, well, here's a link. It's a link in 3D space, probably. And the link is to the destination service. So the source service says, here's a link that you, the user, can follow. And it probably looks a bit like this. Remember the idea of spatial mapping? That's where this goes. In the path, in the domain, you can describe the 3D space where you want to go. And it's going to look like this. There's going to be a protocol at the front, and the protocol is key because every client is going to deal with a different protocol. So when you see the link, the source client asks the destination service, the service that the link points to. And it knows which service to look at because it knows the protocol. It says, are you a valid link? Is this a valid link? Is this something that this user can follow? And the destination service sends a response saying, yes, probably. Here's what I support, here are the systems I support, here's how long this link is going to be valid for. From that, the source client can provide a UI representation of the link to the user. Something like that. It might look like this. You've got a glowing portal maybe. Crucially, up there, it's going to say what the text of the link is. Because one of the key elements here is you've got to know where you're going. It can't just be a system that sends you to any server. And it can't be something that's represented probably by the graphics of the portal, because that can be deceptive. For safety reasons, for security reasons, it tells you exactly where it points to. And because you trust the source client, you trust that it's going to take you to that particular destination. Now, if you decide to go through the portal, you enter the walk phase, and the user says to the source client, where they're connected, please follow this link. The source client talks directly to the destination client, assuming you've got it already installed. If you don't, then it gets more complicated, still doable, but it launches the destination client. The destination client then talks to the service, requests the connection, the service accepts it, hopefully, and the destination client responds to the source saying, yes, this link is good to follow, it's been accepted, we're all set. So then the source client can disconnect. And the user can then go through whatever negotiation is necessary. If they need to log in, they can do that. There's negotiation between the destination client, the destination service. But we're done. You've transmitted yourself from one application, from one metaverse to another. So it should look something like this. And this is the demonstration that we've built. Make that full screen? Yeah, there we go. Okay, so here's the unconnected state of our client, the teleport client. Right, that is not showing on screen. I don't know if people on Zoom can see that, but it's not showing on the big screen.
We're working on the technical details. I'd say, I don't know if anyone's seen the latest Doctor Strange movie about the multiverse and all this kind of thing, but I would say this is basically the closest version that, as far as I know, anyone has built to what the gap junction is in that movie, where there is the transition that takes you in between these different versions. So
That's it. That's it. So I just want to pause it there because this is a link. Now, how a link looks is going to be specific to a particular client. It's important to have some consistency in how the link looks because as a user, you need, again, as a matter of safety, as a matter of privacy, you need to be able to recognize a link because a link is going to take you to a different service, different client, possibly. It's important that you know when you're following, when you choose to follow a link, is that actually going to happen? So we represent it here, but we show as well the protocol, and that's an MMV protocol. Now, MMV protocol, as we built it, means take me to metaverse, which is Joel's system, Joel's metaverse. And metaverse has a different UI to this, has a different visual look, but we're able to transmit ourselves just by following the link. The teleport app launches the MMV app. And we move through the portal, and now we're in a spaceship. So we've navigated through a portal pretty seamlessly, and now we're in a different context, and we can get used to that. Different controls, obviously, probably different representation of how portals look, etc. But crucially, we made the transition.
But with this, sorry, can I ask a question? Is it like if you want to go between, like, say, voxels and spatial, or is this if you?
Yes, it's quite generic because.
Or is this just between different worlds in voxels or spatial?
This is actually between different applications. Now, they could be applications. If it's on the web, then it's easy. So if it's between spatial and something else that's web-based, you can probably just do it with a web link. The problem there is that that would all have to be coded in as probably as JavaScript, which means you're introducing safety issues where JavaScript is essentially taking over navigation and sending you to a different site. So it's better if there's a native client in this case, because the client can provide guide rails essentially to say, this is what a link looks like. These are the actions you have to take to follow it. And that's not well established in WebXR yet.
Can I ask a question? Can you have two windows up or two clients up at the same time?
Yeah.
Yeah.
Yeah, I mean, it's part of the protocol that we're designing is the idea that the link is going to specify whether it's transitional or additional.
Right.
So if it's transitional, the old one shuts down by convention. Or if it's additional, you can have multiple applications connected at the same time.
Right, okay.
Now, can I move on? Okay, there we go. So, future considerations. We need to look at issues of identity. Can you carry an identity from one service to another where that identity is not necessarily already registered on the target service? Security, I've talked a bit about that, but it's a huge, huge issue and it's very, very important. And going alongside that is safety. The idea that you always know what you're connected to. You always know where you're going and nothing happens that you don't choose to happen as the user. And then there are the cool things like shared avatars. Can we, moving from one place to another, take the avatar with us? Again, if the avatar is not necessarily already been created on the target system, can we bake that into the protocol where, with a common language, a common set of features, we can transition and be ourselves in a new space? And obviously shared assets. Can I take my things with me? Can I use them in some way?
No, sorry, but just because that's not possible right now, are you like trying to find? I'm sorry, I'm just trying to get my head around this because it's quite complicated and but like obviously, some like you have just square avatars and some you have like more people avatars. But are you trying to create like an intermediary like business model that you would then use you as the third party between all these worlds, or are you just talking about it?
Yeah, there are business model considerations, but we're not really thinking of that because we're not looking to create something that has a single centralized point of failure. We're looking for something that is a convention that people can adopt and use however they see fit. Building a business alongside that, there are lots of really interesting ways to do that, but it's a question of, do you want to be AOL in 1990 or do you want to be Netscape in 1995? Because AOL and CompuServe and all these other groups, they had, he remembers, they were trying to build, they called it the information superhighway, but they were closed systems, in many ways more capable than the web at the time, but they were in silos. And I'm thinking maybe you want to be more like Yahoo, you want to be more like Netscape. Help to build the ecosystem of an open network, and hopefully the rising tide will lift all boats, and there's lots of business that can be done there, lots of interesting things that can be done. So just a summary, do you want to take it away, Joel?
Yeah, I think we've seen the, one version of this, which is on a screen, and basically you go from one game world to the other, and you can transition between them, and that all works. It was a bit of a challenging thing to get it to work because of all of the things you have to know about both protocol design and how message passing happens inside various operating systems. So it's not really the easiest thing to do, but we did kind of reach the standardization level around that. And I think there's an even more exciting version of it if you look into the future and all the other different metaverse type applications down the line, where you can even have, the full haptic version of it, where you're kind of immersed in some suit and you're going from one world, and, Roderick has a background in physics simulation, so maybe in one world you're a bird and you're flying, and the next one, you're an elephant, and the next one you're kind of riding a race car or some kind of pod racer or something like that. So I think we're kind of moving slowly in that direction, and, there is this kind of open opportunity space in the fact that this spatial internet, as Roderick was saying, was never really created. We have the infrastructure around DNS and ICANN and some institutions that were set up to manage the internet as we know it today, but there are no institutions really that are set up to manage this, and instead we have these siloed private corporation versions, and we really want to basically find the right way to introduce this more sort of open and more robust version. Yeah, thank you.